Hello everybody, Chaz Large here with another Fix It video for you, and on the bench this time we've got a JVC FX-333L tuner, FM, medium wave, long wave, computer controlled tuner, and it ain't working apparently. It's completely dead. So should we have a look and see what happens when we plug it in? Okay, we're plugged in. Power on. Now let's just make sure it is. Yeah, switched on. Nothing coming up on the display. And I can hear a buzzing. So I'm guessing that mains is getting through. Let me just do that again. My glasses are catching. Yep, definitely a buzzing. So mains is getting through, don't need to check the fuse. Right, let's get inside. Looks like it's going to be fairly easy. 1, 2 screws on either end and 3 on the back. Oh, we've got an odd one here. That's an odd one, isn't it? It's got like, it should have like a shank in it, a spare shank for clipping something onto. Perhaps it's for grounding purposes. Could be, being a tuner. On the output side, we've got left and right audio out. No colour on the phono sockets. Red and white is what they normally are. We've got a CompuLink Synchro. That's obviously for, it's obviously picked up my magnet somewhere. That's for controlling it through a system. So when this is all built together as part of a system, you have a jack to jack plug that goes between the two. So you've probably got a remote control or something on the other one. And for input side, we've got FM. Between those two, it's a 300 ohm antenna, and between that one and that one, it's 75 ohm. That's typically for the ones where you have an antenna on the roof with a balanced dipole. And then we've got a loop for AM, of which that's going to become less and less usable in the UK, because towards the end of this year, good old 192 kilohertz long wave is shutting down. Radio 4 is going to be lost to long wave listeners, which is going to be annoying for some people in parts of the world that rely on it, and people who quite often listen to the Archers in the shed on a good old Roberts radio that they've had going for years, and suddenly they're not going to be able to get that Radio 4 anymore on long wave. It's a shame, but I suppose it costs a lot of money to run one transmitter, doesn't it? The BBC are cutting back on everything, so pretty soon we probably won't need an aerial at all, because everything will come through the internet anyway. Most of what I watch on TV comes through the internet. So anyway, let's get the lid off. Run titles. Right, the lid is off and we can see inside there's not a lot to it. Big transformer. It's obviously built to fit a particular size. Is that 19-inch rack mount sort of size? I suppose it could be. Roughly, I don't know, I'd have to measure it. Let's do that. Just out of pure curiosity, in inches. Oh, it's 17-inch, so probably with handles on it would go in a 19-inch rack, but anyway, goes with the rest of the system presumably. So on board we have got 1, 2, 3 chips there. There's one not there, and presumably there is a controller. There's another chip that's not there. There's obviously bits and pieces for different functionality that are not there. Looks like a sort of regulator or something there. Illuminated display, possibly by bulbs, who knows. But I can't see a processor, so I'm guessing it's a surface mounted device that's mounted underneath, although you can normally see it in terms of layout. I don't know, I'll have to have a look at the manual. So yes, there is a big IC big square IC. I'm guessing it's got to be underneath there. Oh, it could. Doesn't show it as on there. Is there a? Let me just zoom right out on that. No, it's not. It's definitely on the main board. It's the big control IC on there. Anyway, I will put this up on the screen during the edit so you can see. So the thing we need to check first off, that's because it's dead, the power supply. So we have got a standard mains transformer with a built-in main fuse on the primary side, but as it's buzzing, I would guess that that's probably okay. Secondary side gear comes out here into a full wave bridge rectifier with a 3300 microfarad 35 volt capacitor across it. So the first thing we ought to do is to check and find that capacitor, which is presumably that one. Okie dokie, and then find if there's any components connected to that we can put a meter on. Oh, there's CP101, which is an ICP. Oh, in circuit protector N5, so that's 500 milliamps if my memory serves me right. So let's see if we can find that ICP. Can't actually see it on the board somewhere. Oh, there it is. Yep, we found it. So I tell you what, let's bring in the close-up camera. So the ICP is way over here. Let's just double check on the diagram. And it's CP101, and that is definitely CP101 just there. Now we've got a bit of flickering going on with the camera. Apologies for that. It's because I've got the blinds open, so we've got daylight frequency upsetting the camera. But there, we can just see it. So we need to get a meter on there and see what we've got. So stick the old ground on there somewhere. I'm guessing ground is ground. Meter on DC. Can we see that on the camera? Yes, we can. So there's ICP. And we've got 25 volts on one side of that. And 25 volts on the other side. So that ICP is okay, so it's not going into there. That must be feeding into this bit of here, which is the 5 volt regulator, I would guess. Because there's a Zener diode there on the base of those transistors. That's only a 10 volt capacitor across it. So I'm guessing that's going to be a 5 volt Zener of some kind. Oh, 6.2. There we are. It says the diode MTZ 6.2 JC. So that's a 5 volt rail for the processor. So it could be that that's at fault. Let's see Q136. Can we find that? Q130, 129. Is it hidden down here somewhere? I'm guessing it probably is. Q132. Oh, is it going to be tucked right in that corner? I bet it blooming well is. Q134. The fact that we've got no lighting up though, just had a thought. We've got no illumination. It's on, or yeah, I suppose if the if that 5 volt rail, that won't turn it on. So if things won't turn on, there we are. So, but where's the power control come from? Let's just have a look. We got power out of that processor somewhere. There's usually a line marked power or con or something like that. Well, there's a switching transistor. Doodly-doo. There's power. So power comes from, might be able to get to there, to this IC, which is IC102, IC102, 104, 105, 102 is down here. Let's get that on camera for you. IC102, and it's in just about in focus. So where's my probe gone? So the power control comes out of pin 9 of IC102. So there's pin 1, 2, 3, 4, 5, 6, 7, 8, 9. So we got 37 millivolts. Let's switch the power. So we can see on the meter there. Can you see on the meter? Probably not clearly enough. Right. So I'm on that output of pin 9 of IC102. Hit the power, and we're getting 35 millivolts coming out of there, or going away when we power it again. So we are getting control. So I'm going to guess that this supply rail into the chip is okay. Q136 might be a surface mounted device on the underside of the board, because I can't see it anywhere around here. That's 1, 2, 4, 1, 3, 2. Right. So I'm going to guess that is under, and that's working, because otherwise this chip wouldn't be switching, would it? Come on, think about it, Large. Right. Okay. So that power control comes down here to Q134, and then that controls IC103, which is a regulator with some volts. Let's zoom in on that. Where have I done? There it is. So poor circuit diagram, we should have 17 volts going into pin 1. So there's the regulator. Just let's get that on the camera. So your guess is as good as mine, which is pin 1. So one pin will have 17 volts on it. So let's go at this end and guess that that's pin 1. It's not that one. Is it that one? 25 volts. Well, 17 volts when working, I would guess. Switching. Right, so that's pin 1. So pin 2 is ground. Pin 3 is probably the output. Yep. So pin 3 should be the output. That should be pin 3 there. And we're getting 500 millivolts. Let's switch that transistor. And we got 0.6 of a volt. Well, it is switching to a certain degree, but we're not getting pin 3. We're not getting the 12 volts we should be getting out of it. So I guess possibly. So let's just check pin 4 and see. Well, we looked at pin 4 earlier, didn't we? And we saw there was 0 volts. So nothing's happening with there, but we are getting on this. We are getting that power control coming down to the base of Q134. That's switching, but there's no change in there. Has Q134 bit the dust? It's a digital transistor. There's Q134. We can just about see it on the camera there. So there's the emitter, which goes to ground. So that should be ground. Collector should be the middle one. And that's also 0. And then the base, which is the control from the power switch, is there. Hit the power switch and it's going up and down. I suspect Q134 is a goner. Oh, a nice quick and easy fix. Let's put some ohm meter resistance check on there. Check my meter is working. 0 ohms. Let's go between emitter and collector. So that's the middle one. That's the bottom one. Oh, that looks like a dead short to me. Let's even go on beep mode. That's the probes. Oh, if it's not dead short, it's very low, is it? Oh, yeah, there it is. It is. I suspect it's that transistor. Right. Let's unplug and get the old board out of there. So what have we got to do to take this board out? Let's close that. I'll tell you what. Let's have a quick slurp. Ah, nice cup of tea. Can't go wrong. As Doz quite often says, time for a tea break. Yeah. We like old Doz. Doz is his television workshop. Doing the job I used to do many, many years ago. Both of us. I bet if I got together with him, we'd be talking for hours. Right, in here we have got, on the overhead camera, we can see we've got 1, 2, 3, 4 silver screws to hold that down, and we've got 1, 2, 3 screws on the back panel. So let's get those off first. So handy having a little magnet. I must put it on a stick of some kind. Right, so that's all the things loose. Is that loose, or is there another screw somewhere? No, it's moving sideways. I think, yeah, I think probably best if I take this back panel off as well. What have we got? 1, 2, 3, 4. Oh, somebody's been in here before, look. Somebody's been in here before. They put arrows on the silver screws. Do you know, I thought those screws, when I took the back out, were a little bit on the loose side. Somebody's been in here before. Probably said, oh, it's the microprocessor, it's the chip gone. I've not progressed it any further than that. I can see why they marked them, because there's 2 holes here that have got no screws in. Well, there you go. The chap who sent it to me didn't say it had been elsewhere. Oh yeah, and that little cable clip down there is loose as well. That should have been done up. Definitely, I should have seen the warning signs. Right, and the board comes out really easily. There's the processor. See, it's yeah, you can just see it now on the top here. You can just see the outline underneath that thing. Right, so we are looking at Q134, which it's right next to the capacitor. There's the capacitor. Q134, and we're looking at emitter collector short. Let's go back on there, use beep, and just double check again. Those 2. Yeah, righty ho, soldering iron on. So what is that transistor? Let's have another look back at that. It's a DTA 114Y. Now, in a square box means it's a digital transistor. It's a PNP, piston in pot, arrow going inwards. Just in case you didn't know, you could tell the difference of what type of transistor it is by the arrow. So PNP, piston in pot, the arrow's pointing inwards. This will probably get edited to get that naughty word out, but I don't care. So it's a digital transistor. All it means really is that it is a transistor with built-in resistors, so you don't have to build a circuit around it for biasing. That's all it is. It's a standard PNP transistor with built-in resistors. So let's have a look and see if I've got any digital transistors. Let's see what else we've got. What are they? No, you're joking. I've only got a packet of them. A packet of DTC 114s. I don't believe it. I don't believe it, Grandma. How about that? I must have worked on something like this before. Or it's a very common transistor because I've got a packet of them. Yeah, there it is. Let's just check it. Right, so we're going to check this transistor out, won't we? So we've got a meter on ohms. It's a brand new transistor, so it should check all right. There we are. That checks fine. Oh, where would I be without my book? I tell you what, I've had this book for donkey's years. Where are we? Now, Jaeger Electronic 93. That was brand new, 1993. But there's, I think, I'm not sure whether it's still in publication, but it's got loads of transistors in and equivalents. So much quicker than having to type things into the internet. Right. Let us take this transistor out. Triple check that I've got the right one. There it is there. Right next to capacitor. Clean the soldering iron. Use desoldering braid. Well, tell you what, this soldering braid has been around for a while, so I'm going to just put some fresh solder flux onto it. That should desolder it much better. Yeah. Clear. There we are. Take the transistor out. Okay, get my meter on just to make sure it is faulty. Yep, definitely faulty. Right, let's get this one sorted. There we are. Just trimmed up the legs a little bit just to make it easier to get in, because sometimes I find wires that are too long, they bend all out of shape. Oh, I've dropped it now. Where's it gone? Oh. There we are. I've got the legs length just about right. Fold them over a little bit. Hold in place. Normally I chuck wires straight in, but anyway, there we are. Because it's the right type, it's just gone in exactly the same. There we are. Right. Let's put the board back in here. It's a bit fiddly. It's not often that I've got that's the back screws, isn't it? That's the chassis screws. They look exactly the same, so but we'll put this one in here because it's got a grounding on it, and then we'll test it. before we do any more. Right, let's see, have we brought the little beastie back to life? Okay, nothing's shorting out that shouldn't. Everything's just resting as it should do. Power on. Still dead. Is it dead? Yeah, it seems to be. Oh dear, I thought we got it. Thought that was the be all and end, unless it needs other earths. Occasionally it needs multiple earths. And one at the front here as well. Let's try it again. Alright, still dead. Oh dearie me. Oh dearie me. I did put it in round the right way, didn't I? That transistor. Okie dokie. Let's connect that to there. And that should be the out. Oh, let's put it on volts. So that's the output, 13 volts. So that's definitely on. We're getting 13 volts output. So why are we getting no display? Actually, I think it is coming on, it's just that the lights aren't. Yeah, it is, it's just that the lights aren't working very well. Haha! We've half fixed it. It's these lights aren't working. Now, are these lights connected to these plug and socket? Tell you what, let's apply our own illumination. Yeah. Right, can you see that with the camera? Probably not. Let's bring that one in so you can see. Right, so that's my own illumination from the back. It is switching on. So we have no illumination from these lights that are in there. And they are both, are they being fed by these wires here? I think they are. Let's check volts across those lights. Okay, so there are two lamps which have gone out. Minus 11 volts on that one and that one. Right, let's have a look at this, the old circuit diagram. Let's take that out. Let's check. Oh, that regulator's getting a bit warm. Does that regulator feed? Where's my mouse gone? Zoom out. Now, there should be indicators of dial lamps somewhere. That's J201. Let's zoom out to that. I'm missing it somewhere. It's going to be blindingly obvious when I see it. Ah, there it is. So we've got two lamps. One lamp goes to ground, one lamp goes to ground. And yeah, so we should have 16 odd volts across both lamps, and one side goes to ground. So let's power that off. Tell you what, let's take these lamps out of here. This comes out with a little clip, I think. Is it a clip release or a push down release? I think it's a push release. Yep. So that presumably is one lamp, because those two came out close together. So let's go on to one of these wires. And then go onto here. So that's open circuit between those two. That's open circuit. That's open circuit. So those lamps appear to be open. Yep, it would appear that all these lamps are gone. Have failed. So those lamps are running on this supply rail, which should be 11 volts coming out of there. So they're 12 volt lamps. So you know what lamps we can use? Good old video recorder lamps. They're all tangled in there, so we're going to have to just, let's pull that up there for a minute. Right. So have we undone all the screws? Oh no, I left this one. So let's cut these cable ties. If we cut them in such a way, we might be able to reuse them. Cut them just before the tab. And actually, can we just pull them out? Yeah. They're just mounted in rubber mounts. Let's put the other one in there. Yeah, so that the pair I got round the wrong way. Let's put my old magnifier on and have a look. Yeah, that one does not look broken. This one definitely did. No, perhaps they're just dark. But let me just put my meter across them again, just to make absolutely sure I wasn't dreaming. Right, meter across that lamp. definitely faulty. Meter across this one. Definitely faulty. Right, both of those lamps are kaput. Tea time. Dial lamps. God, it's been a while. Dial lamps. I've even got a drawer for them. Look at that. God, those of you watching will say, oh, I know what that is. That's from a Ferguson VC whatever, or a JVC whatever, or something like that. Yeah, and I think they might have been second-hand rescued from a scrap unit. Or there's this one, and I've even got a packet of new ones. Look at that. Ah, but that's only 4.5 volts, so that's no good. Huh. Fairy lights. Everyone, fairy lights. I've got some little bulbs, plug-in bulbs. I've got a load of those. So we need to check and see what sort of voltage these run at. So let's have a look over here and go to the power supply. Oh, it's me on the other camera. So power supply on. I don't suppose you can see very well on this. I've got it set to 3 volts. Right, so 3 volts, output on. We've got a low glow, gradually warming up to 5 volts, 7 volts, 12 volts. We have one light, 12 volts. This one works okay. Whiz that back down. So we've got one lamp. We've got another one of these. I'm pretty sure these are going to be 12 volts from the old Ferguson video range. We're still output on. Winding that up. 12 volts. Yeah, nice and bright. We're okay. What I may do at some stage is to rewire them, use these wires for some other purpose, because they're always useful to have. So having done that, I now need to remember which connectors which had the supply rail on the diagram. So 2 pins go to ground and 2 pins go to 12 volts. So that should be easy enough to determine. We put that to ground. Should put it on beep, that'll be easy. Beep, beep, live. Right. Let's put a little line on those two for ground. Push one into there. They're just, I think this was obvious, fairly obvious that they planned, or in the design of this, that these bulbs would fail and these are be an easy way to replace them. Ground. And supply. Oh, that didn't go in. It's a bit banked up as well, that connector. We'll obviously use this lamp elsewhere, or it's recovered from. Second-hand parts are so useful. Occasionally people give me old stuff and say, do you want this? And I say, yeah. And they say, what are you going to do with it? I say, take it to pieces. And then I'll sort it into all my little drawers. Right, lamps are fitted. And we have power. Look at that. Right. So we should now be able to push these into here. Although I think really and truly it needs the little rubber bung to go all the way around it. It's like putting something on a tiny sleeve, if you know what I mean. At least if nothing else, we've got it switched on. We've got light illuminating the display. But it may be that the damn thing don't tune into anything. Right, power on. And now we have a display. Look at that. Lovely jubbly. Nice display. Let's put that and that over there out of the way for a minute. Amplifier on. Auxiliary to select. Yep. FM mute is on. Aha! FM mute, in case people are not used to it, is a bit like squelch control on CB radios. We won't get much of a signal in here anyway, but it will do for testing purposes. So 75 ohm on that one. Right, it's lost all its presets. 89.5 should be radio 2.
2014 when they just woke up one morning.
Look at that.
An album just on our computers.
We have got a working tuner.
Just a software update. Just a weird decision, marketing decisions.
I'll turn the lights off.
I've got an idea. Instead of people choosing to listen
Much better without the lights on.
It directly into their souls. mad moment, really backfired as well. Oh, before we have the travel, we're chatting Sunday dinners. Yes, we've got a voice note. Hi,
Right. Right. I think we'll stick it all back together and make sure it still works. Let's turn the lights back on. I'm pretty sure we are good to go. There we are. One repaired JVC tuner. Power on. Lights on. Nice display. Connect antenna to that. There.
Police said they're not looking for anyone else in connection.
Yeah, working nicely. I'm pleased with that. Nice little repair. Hope you've enjoyed this little dive into a dead JVC tuner. Thanks very much for watching. Hope you've enjoyed it. Click like and subscribe, as Doz says, or not. It's up to you. Appreciate you visiting the channel and the support and the comments. Thanks a lot. Bye for now.